Hi, welcome to this video tutorial about levers. Levers are the most commonplace of all the simple machines. From shovels and knives to wheelbarrows and baseball bats, levers are everywhere we look. There are several components that every lever has, so let's go over and review those. Every lever must have a fulcrum, a point at which the lever rotates, a resistance, the force acting against the effort applied, and obviously the application of effort to move the lever. There are three classes of levers. They are differentiated by the positioning of the fulcrum, resistance, and application of effort. In a first-class lever, the fulcrum is between the effort and the resistance. A seesaw is a good example of a first-class lever. When effort is applied to force one end of the lever upward, the end where the force was applied must go down. Like a seesaw, the shorter the distance between the fulcrum and the resistance, the easier it will be to move. This is a result of the mechanical advantage, but we'll get to that later. Second-class levers is where the resistance is in between the fulcrum and the effort, whereas a first-class lever is able to increase force and distance through mechanical advantage. A second-class lever is only able to increase force. A common example of a second-class lever is the wrench. The force exerted by your hand at one end of the wrench is magnified at the other end. Basically, with a second-class lever, you are producing greater force at the other end. In a third-class lever, the force is applied in between the fulcrum and the resistance. A baseball bat is a classic example of the third-class lever. The end of the bat where the ball is struck is the resistance. By exerting the effort at the base of the bat, close to the fulcrum, you are able to make the end of the bat fly quickly through the air. Now that we've defined all three classes of levers, I'm going to show you a series of images. Now I want you to identify each one of these images as a certain type of lever. Let's get started with this first image. What is it? First, second, or third class lever? That's right, second class lever. Because the resistance is in between the fulcrum and the effort. Here's another image to identify. This is a third class lever. Look at where the force is applied. It's in between the fulcrum and the resistance. Like a baseball bat, this is a third class lever. I hope that helps. Thanks for watching this video tutorial.